Hey guys, Mr. Decker here. This is lesson 5 of the physical computing unit, and we're working on board events today. The onboard event block allows you to start taking input from your circuit playground. Look at the program and discuss what you think it'll do. Once you've come up with an answer, click Run to check your answer. All right, let me get this little guy out of the way. Okay. So we have on line 1, we've got an onboard event, button L down, and inside that onboard event, I'm assuming this works like the on event. So in an on event handler, we have buttons on our app that we can press or things that we can interact with here to make things happen on the circuit playground. But with this event, I'm assuming I'm going to be hitting a button on here. I'm assuming because it's saying that it's going to be, let me make this bigger. It's going to be the left button. So I'm assuming the left button, when I push that down, the LED is going to turn on. So let's type our answer out. Press button L on the circuit playground. The red LED will light up. All right, let's run this. And let's see, so again, making this bigger. The left one, boop. And the LED lit up. Cool. Okay. I was right. Let's finish and continue. Using board events. Right now, the LED turns on when the left button L is pressed down. It should turn off when the right button R is pressed down. Do this. Add another onboard event block to turn the LED off when the right button is pressed down. So we need another onboard event. It looks like there's already a comment here. When button R is pressed, turn the red LED off. So LED off. We want to choose the button R label or ID. When that goes down, LED off. So let's run and see if that works. So again, making this bigger. There we go. Find the webcam. It's a little awkward presenting this way. Okay. So left button turns it on. Right button turns it off. So this is the right. This is the left. Hitting left. Oh, hitting right, left. This is left. This is right. Oh, getting oriented. Okay. Boop. That's turning it on. This turns it off. On, off, on, off. Now we're nailing it down. Okay. So we got that to work. All right, moving on. Bubble 3. Other board events with the buttons. Instead of using the right button, you can make the LED turn off when the left button comes back up. Do this. Create an up event for the left button, and then add code to turn the LED off when the button pops back up. Okay, so we need an up event for the left button. So onboard event, button L up, Then we want to turn the LED off this time when the button comes back up. So let's try this out. So we run it. And let's see. Oh, okay, cool. So again, this is left over here. I'm holding it down. I'm letting go. Holding it down, letting go. So when you're holding the button down with this programming, the light is on. As soon as that button goes back up, boop, it's off. Very cool. So we'll finish and continue. Let me get my big head out of the way. All right. Using the toggle switch. The toggle switch can flip in one of two positions, open and close. This program uses it to make a light switch. Right now, it can only turn the light on. Do this. Create a new toggle switch event that is triggered when the switch is flipped to close. Okay. Add code so that when the toggle switch is flipped to close, the light turns off. So we need another onboard event. And we want to say when the toggle switch, so toggle switch from this ID drop down, from the property, close, and we want it to turn off. All right, so the light should be on when the toggle switch is open and off when the toggle switch is closed. So if I run it, let's go ahead and make my head big again. Run. All right, let's find the camera orientation. So the toggle switch is this right here. And I think, let's see. Okay, so that is open. So moving it this way opens it, and then moving it back the other way, boop, turns it off, and it's closed, kind of like a light switch. Cool. Like opening and closing a circuit. Open, and let's close it again. Boop. Perfect. We're getting it. We're getting it. All right, moving on. Bubble 5. On bubble 5, we've got another question here. So more on the toggle switch. You can also check whether the toggle switch is in the open or closed position anywhere in your program. What different things does the button do when the toggle switch is open or closed? So this time we've got a conditional nested inside of our board event. So on board event, button L down. If toggle switch is open, the LED will be on, else the LED is off. Okay. So for this one, if the toggle switch is open, the LED will turn on when you press down button L. Else, if the toggle switch is closed, then the LED will be off. And won't turn on even when button L is pressed down. All right, let's try it out. So let's run it And I'm not sure exactly which position the toggle switch was left in from the last bubble. So let's see. Oh. All right, so button L, right, doing nothing right now. So I guess the toggle switch is closed. So when the toggle switch is open, now, okay, now it turns on because the toggle switch is in the right position. So, or in the open position. So with it in the closed position, oh, okay. So with the toggle switch in the closed position, you can't get it to turn on. With the toggle switch in the open position, you can turn it on, but you can't turn it off. And then if you switch the toggle switch back to closed, the light stays on. And then if you hit or press down button L, then it turns off. So that's a little more complex than I even imagined. Very cool. All right, moving on to bubble 6. State and the toggle switch. Okay. This program tells you, let me version history this, make sure that I don't have code in here that you shouldn't be seeing yet. All right, this program tells you whether the toggle switch is opened or closed, but it needs the toggle switch is open block to work. Toggle switch is open is true if the switch is open and false if the switch is closed. Okay, do this. Complete the if statement with the toggle switch is open property. Complete the if statement with the toggle switch dot is open property. So right now we've got a blank spot here in if. So in this if statement, okay, so over on circuit, toggle switch is open. So if toggle switch is open, then this open underscore close ID for this text right here, it will say open, else it will say closed. So let's run it. And let's see if it works. So the toggle switch, let's switch it. Oh, wait. Okay, so I'm also supposed to be holding button L down. Let me get that out of the way. So it's closed right now. Let's see, let's switch it to open and then hit button L. Now it says open. We'll switch it back to closed. Button L, closed. Switch the toggle switch again. Button L, open. Okay, cool. Pretty simple. I like it. Let's finish. Finish. Okay, there we go. Continue. On to bubble 7. All right, workspace. This icon means that this level is part of a larger project. Changes are going to be saved across these levels. Okay, of course, that symbol right there. And let's see. Let's version history this. Okay, using the buzzer. You can use the buzzer in a lot of different ways, but right now we're just going to use the buzzer.frequency. Do this. Pull out a buzzer.frequency block from the toolbox and play around with it. You'll notice it has 2 parameters. What happens when you change either or both of those? And then run the program and enjoy the music of your circuit playground. Oh, I'm sure it just is going to serenade us in the most beautiful sound known to man. Okay. All right, so buzzer frequency, drag your buzzer block here. So we're only working with buzzer.frequency. So this first parameter is frequency. The second parameter is duration. So they're both numerical values. And I'm imagining the frequency increases with the increase of this number. So first we'll just run it. Did you hear that? It's subtle at this point. Okay, so frequency and duration. So if I increase the duration to say 999, right? Reset, run. Now I know you heard that. All right, let's see what frequency does. Let's change this to like 50 instead of 500. All right. 999 might be ear piercing. Yeah, that's ear piercing. Okay, so basically you increase the frequency or decrease the frequency, and that makes the sound that it produces with the buzzer either decrease with a lower value or increase with a higher value. And then with the duration, right, with a 50 here, it's just like a chirp. With a, let's see what a 200 does. And let's lower this so it's not, whoop, no, it's so annoying. We'll just do maybe 300. Reset, run. All right, so a shorter one. Let's try like 700. Cool. All right. Finish. Continue. Bubble 8. As you've noticed, buzzer.frequency has two parameters, frequency and duration. Both of these take a number as input. Frequency changes how the buzzer sounds. The bigger the number you give it, the higher the buzzer sound will be. Duration determines how long the buzzer is going to play a sound for in milliseconds. For right now, we're going to focus on duration, the second parameter. Okay? Try out a few things with duration. Change the duration of the buzzer to something longer than 100. Try setting the duration to 0. What happens? Yeah, what happens if we do it to 0? We've already tried values bigger than 100, so run. Okay, that's annoying. So if you have it set to 0, it just goes forever. What about, I don't know if it'll even take a value bigger than 999. Okay, let's try 3000. Okay, so clearly we can put some big numbers in here. All right, so we ran it multiple times before we moved on. Finish, continue, bubble 9. Buzzer and the buttons. This program should use the buttons to play long and short buzzes. Do this. Change the duration parameter of buzzer frequency or buzzer.frequency to make the left button play a long buzz and the right button to play a short buzz. Let me version history mine. So right now these are empty, but we want buzzer frequency and buzzer frequency in both spots. So for the button L, we'll play a long buzz. So frequency and then duration. So we'll do 2000 here for duration. And then down here, we want it to play a short buzz. So we'll do something bigger than 100, but 200 will be fine. So we'll run this. And then whoop, 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 hitting the left button makes the long buzz, and then the right button makes the short buzz. Perfect. All right. We'll finish right there. this was a fun little one. It might be annoying in class, though, because I guarantee a lot of you are going to be hitting that buzzer a lot.